Ever wondered why your phone charger seems to work so incredibly fast these days? It's almost magical how quickly our devices power up. Or have you pondered how electric cars are able to go farther and farther on a single charge, pushing the boundaries of what's possible? What's the secret behind this extended range and improved efficiency? The secret, surprisingly, lies in a tiny yet incredibly powerful component, the nanocrystalline core. These cores are revolutionizing the way we use and conserve energy. These are special magnetic materials, meticulously engineered at the nanoscale, that play a crucial role in controlling electricity in countless devices, from the smallest gadgets to large-scale industrial equipment. They are the unsung heroes, quietly working behind the scenes, making our tech smarter, more reliable, and significantly more efficient. Imagine a magnet, but not just any magnet, one that's been specifically engineered and optimized for use in high-tech circuits. These advanced materials are the very hearts of inductors and transformers, the components that regulate and transform electrical energy. So, what exactly makes them so special and uniquely suited for these critical roles? The answer lies in their composition. They're made of ultra-tiny crystals, so incredibly small that you'd need a powerful microscope, like an electron microscope, to even begin to see them. This unique nanoscale structure gives them extraordinary magnetic powers and properties that older, more traditional materials simply can't match in terms of performance and efficiency. From the intricate circuits within our computers to the vast network of the power grid, these nanocrystalline cores are essential for keeping everything running smoothly, reliably, and efficiently. In essence, they're like tiny, highly skilled traffic cops for electricity, meticulously ensuring that power goes exactly where it's needed and doing so with minimal waste and maximum effectiveness. And as we continue to move toward cleaner, more sustainable, and increasingly battery-powered technologies, these remarkable cores are playing an increasingly vital role in helping us build a greener, more energy-efficient future for all. So, let's dive in and explore the fascinating world of nanocrystalline cores and discover just how these seemingly invisible giants are quietly, yet powerfully, powering our modern world and shaping the future of technology. Welcome to another video by Adeptis Academy. Let's break down nanocrystalline. Crystalline refers to atoms in a highly ordered repeating pattern. Nano signifies 1/1,000,000th of a meter. Nanocrystalline means crystals smaller than 100 nanometers, observable only with powerful microscopes. Why does this smallness matter? In magnetic materials, smaller grains make it easier for magnetic domains to flip direction. This means less energy lost as heat and quicker response to electrical signals. This is called low coercivity, needed for high-frequency electronics. The result? More efficient devices that run cooler. Nanocrystalline materials allow us to make modern electronics smaller, faster, and more powerful. This seemingly insignificant alteration has a massive impact on technology. That's why these materials are found at the heart of today's most advanced devices. Making a nanocrystalline core starts with a special molten metal alloy, usually iron, silicon, boron, plus a dash of copper and niobium. The molten mix is rapidly cooled by spraying it onto a spinning, ice-cold wheel, freezing the atoms in a random glass-like state. This creates a thin, flexible ribbon, an amorphous metal. Next, the ribbon is shaped and heated in a precise process called annealing. The heat lets atoms form ultra-tiny crystals, thanks to the copper and niobium controlling their size. This two-step process, super fast cooling, then careful heating, creates a core with both high magnetic strength and easy magnetization. The result, a material that's perfect for high-performance electronics. It's a blend of science and engineering that packs huge power into a tiny package. That's how nanocrystalline cores are born, ready to transform our devices. Nanocrystalline cores have some serious superpowers. First, they waste far less energy as heat-meaning devices run cooler and more efficiently. Their high magnetic permeability lets them concentrate magnetic fields so components can be smaller and lighter. They work brilliantly across a wide range of frequencies, unlike older materials that struggle at high speeds. This makes them ideal for everything from laptop chargers to the power grid. They're also thermally stable, keeping their performance even as temperatures rise. That means more reliable electronics, whether in your car, your home, or industrial equipment. These properties are why engineers are turning to nanocrystalline cores for the next generation of technology. They're the unsung heroes making our gadgets faster, cooler, and more dependable. Let's see how they stack up against traditional materials. For years, engineers relied on silicon steel and ferrets for magnetic cores. Silicon steel is well suited for large, low-frequency transformers. However, it's heavy and inefficient at higher frequencies. Ferrets offer better high-frequency performance, but they can't handle the same magnetic power as silicon steel. Nanocrystalline cores combine the best of both, high magnetic strength and excellent high-frequency performance. This allows for smaller, lighter, and more efficient components. They exhibit lower energy loss, resulting in less heat and extended lifespans. Transformers with nanocrystalline cores can be up to 80% smaller and lighter. From smartphones to electric vehicles, nanocrystalline cores are making a significant impact. Switching to nanocrystalline cores is a fundamental upgrade. Nanocrystalline cores are hidden inside many devices you use every day. They're the reason your phone charger is so small and fast. Less energy wasted as heat means a tinier, cooler charger. In high-end audio gear, they filter out electrical noise, delivering crystal-clear sound. They're at the heart of power supplies in computers and TVs, making them more efficient and compact. Even safety devices like GFCI outlets use nanocrystalline cores to detect tiny electrical leaks and protect you from shock. Their high sensitivity and efficiency make them perfect for these critical roles. By enabling smaller, more reliable, and energy-saving electronics, nanocrystalline cores are everywhere, even if you never see them. They're quietly making your tech safer, better, and more efficient. Next, let's see how they're powering the future of energy. From your home to the grid, their impact is everywhere. Nanocrystalline cores are key players in renewable energy and modern power systems. In solar and wind, they're used in inverters and converters, making energy conversion more efficient so more clean power reaches your home. In wind turbines, they help stabilize and smooth out variable electricity before it joins the grid. Upgrading the power grid with nanocrystalline transformers can save massive amounts of energy and cut carbon emissions. Electric vehicles also benefit. Onboard chargers and inverters with nanocrystalline cores are lighter, smaller, and more efficient. This means longer driving range and faster charging. By reducing energy loss at every step, these cores are making renewables and electric vehicles more practical and appealing. They're helping us build a cleaner, smarter energy future. The ripple effect of this technology is just beginning. Nanocrystalline cores are driving three big benefits: higher efficiency, longer-lasting devices, and major energy savings. By slashing energy loss, they keep devices cooler and use more of the power for actual work, not waste. Cooler operation means less wear and tear, so electronics last longer and are more reliable. That's good for your wallet and the environment, with less e-waste piling up. On a global scale, billions of efficient devices add up to huge energy savings and lower carbon emissions. It's a small change with a massive impact, helping fight climate change one device at a time. Nanocrystalline cores let engineers design smaller, lighter, and more powerful products. They're making renewable energy more effective and the power grid more robust. This technology is about doing more with less, smarter, greener, and more responsible. The quiet revolution inside our electronics is changing the world, and it all starts with these tiny, powerful crystals. Nanocrystalline cores are quietly reshaping our world, from phone chargers to national power grids. Their ability to make electronics smaller, lighter, and more efficient is driving the next wave of innovation. As our world becomes more electrified, demand for these high-performance materials will only grow. Researchers are pushing the limits, creating even better cores for extreme conditions and new applications. Imagine wireless charging everywhere, smarter medical devices, and more efficient space tech, all powered by nanocrystalline innovation. The biggest breakthroughs often come in the smallest packages. By mastering materials at the nanoscale, we're unlocking solutions to our biggest challenges. The future is bright, and at its heart are these tiny, powerful nanocrystalline cores.